Okay, so you're here one last time to see examples of net ionic equations. So I'm going to work four problems from the pack that you got in class. So I'm going to start with 2006A. So if you have solid potassium chlorate is strongly heated, and you have to predict one, what the products are, and then two, what are their states of matter so that you can write a complete and a net ionic equation. So the first thing that I would do is I would figure out, well, what ions am I talking about? So I have potassium, which is a +1 charge, and chlorate, which is a -1 charge. So when you go to make that formula, you're going to have KClO3. The charges will cancel. And it says right here in the problem, solid. So I can go ahead and assign that, that compound to be a solid state of matter. Right, next, I need to figure out, well, what products am I going to make? So this is a metallic chlorate. So from your rules, metallic chlorates, when they're strongly heated, and I really should have a triangle over this. When metallic chlorates are strongly heated, they're going to decompose into a metal chloride and oxygen gas. So I'll have potassium chloride, and it's going to be a solid, and oxygen gas. And the only thing I need to do now is balance the equation. And as you can see, I need a 2, a 2, and a 3. And that's it for that reaction because I have solid, solid, gas. So since those are not aqueous states of matter, I cannot dissociate them into ions. So this molecular equation I'd leave it like that. I wouldn't have a complete or a net ionic equation. That would be it. Okay, the next reaction I'm going to look at is C. It says B in my writing, but it's C. So you have a solution of ethanoic or acetic acid is added to a solution of barium hydroxide. So I have solution and solution. So I know that my reactants are going to be aqueous. So the first thing again that I would do is figure out, well, what are my ions so I can make my formula. So acetic acid, if you have an ic acid without hydro on the front, an ic acid tells me I have an oxy acid, and it's the 8 or the ATE version of that ion. So I'm going to have acetate and then a hydrogen ion, and then I have barium hydroxide, so Ba +2, and then hydroxide is OH -1. So these charges will cancel, and I will need 2 of these hydroxide ions, but I need to put them in parentheses in order to balance out that +2 of the barium. Okay, so what you should get is, acetic acid, it's aqueous, barium hydroxide, it's also aqueous. This is a double replacement reaction, so what I would do if I were you is rewrite your reactants, keep the metal, or keep the first element in each compound in that position, and what you're really just doing is you're swapping the anions of each compound. Okay, so that's what I've done here. I've kept the hydrogen where it is, I've kept the barium where it is. And now instead of pairing the hydrogen with acetate, I'm going to pair it up with the hydroxide to make HOH or water. And I'm going to pair up the barium with the acetate. Okay, so I need 2 acetate ions to balance out the charge of the barium ion. I should have written this here. This is aqueous. This is an aqueous solution. Water is liquid. And if you look in your solubility table, acetates, as long as they're not acids, will be aqueous, and you can dissociate them. So when acetate is with an acid or with the hydrogen, do not dissociate. When acetate is with a metal, you will dissociate that. Okay, so right here we have our molecular equation, and it's balanced. All right, now I'm going to split everything that I can split. So again, the acetic acid, don't split because it's a weak acid. Barium hydroxide is soluble, So I can go ahead and split that into ions. Water is a liquid, don't split it. Barium acetate, absolutely soluble, split it into ions. And then I look and I see what's the same on both sides. So if I look right here, the only thing that I have the same on both sides is the barium ion. That's my spectator ion. I started out with barium plus 2 ions. I end with barium plus 2 ions. So there's no change there. So the barium ion's really not participating in this reaction. But everything else changed in some way. So I have to leave everything else. So I'm just going to pull down all of my reactants that are left over and my products that are left over. And there's your net ionic equation. So you have acetic acid plus the hydroxide ion plus water yield, plus the hydroxide ion yields water plus the acetate ion. Notice that I don't have these 2's anymore because an equation should be the lowest whole number coefficients for each reaction species. So you could put the 2 in front of each of these ions or molecules, but that would really not be most correct. So you need to reduce all your 2's down to 1. So there's your net ionic equation for part C of 2006. Okay, then we're going to look at letter E. So we have zinc metal is placed in a solution of copper 2 sulfate. So zinc metal is telling me that this is a solid. When metals are solids, they do not have a charge. So zinc will have a charge of 0 as a solid when it's not in a compound. Okay, and then the copper 2 sulfate, I have Cu plus 2 and sulfate is SO4 minus 2. So there are my reactants. Again, zinc is solid, copper 2 sulfate is aqueous because sulfates are going to be aqueous as long as they're not with your heavy metal bad guys, silver, mercury, and lead. And this also did say I had a solution of copper 2 sulfate. So this is going to be a single replacement reaction. The zinc will kick the copper out of this solution and replace it, and then the copper will be by itself. So you'll look like this. When the copper is by itself, it will no longer be an ion, it will be a solid. Okay, I'm sorry I got interrupted here. So I'll have solid zinc, copper 2 sulfate solution, and then zinc sulfate is going to be a solution. If you look at your rules for Cashingia, sulfates are soluble as long as they're not with the heavy metal bad guys, and zinc is not, so it's going to be an aqueous solution and then a solid copper. So I need to take these aqueous solutions and dissociate them into ions. So there you go. And then look and see what's the same on both sides. So please be very careful. Zinc metal and zinc ions are not the same. Neither are copper ions and copper metal. So zinc metal would be solid metal atoms, whereas the zinc ion is a positive 2 ions surrounded by water molecules, hydrated by water molecules. So they're not the same. So you can't cancel any zinc or copper out, but the sulfates are the same on both sides, so you can cancel those out. And so your final net ionic equation would be the red here. So you've got zinc solid metal plus copper ions yields zinc ions plus copper metal. Okay? And then the last one I'm going to do here is, I believe, G. So we have a solution of nickel 2 bromide is added to a solution of potassium hydroxide. So again, 2 solutions. So I know that my reactants are going to be aqueous. Nickel is there, I'm told it's a plus 2 ion, so Ni plus 2. Bromine has a minus 1 charge, potassium plus 1, hydroxide minus 1. So these charges here will cancel, but I'm going to need 2 bromide ions in order to cancel out that positive 2 charge. So there are my reactants, aqueous, aqueous, and this is going to be a double replacement reaction because that's compound plus compound. So again, leave the first two ions in each compound where they are. Don't change their position. And I'm going to switch out the hydroxide and the bromide ions. Okay, so just keep in mind potassium and bromide, their charges will cancel, but the nickel and the hydroxide, their charges will not cancel. So I need two of these hydroxide ions when I make the nickel 2 hydroxide. So there we go. And then we need to balance, so I need a coefficient of 2 in front of the potassium bromide and a coefficient of 2 in front of the potassium hydroxide. Then I need to look up in the table. So group 1 metals, always going to be soluble. And then bromine is a halogen, and halogens are soluble as long as they're not with heavy metal bad guys. So I'm good both ways. The group 1 metal definitely makes us aqueous, and the fact that the halogen is not with a heavy metal bad guy makes it aqueous. But nickel, unfortunately, makes this hydroxide insoluble, so it's a solid. So there are my phase designations, and then again, split what is aqueous. So there's my split. Look for your spectator ions. So your spectator ions, I've got potassium, same on both sides, bromide ions, same on both sides, and so I'm going to cancel those out, and then everything that's left over, that goes into my net ionic equation. So my net ionic equation there is in green. Please keep in mind that you have to be charged balanced on each side. So over here on the left, I have a +2 charge and a -2 charge. So overall, that's a net charge of 0. And on the right, of course, I have a net charge of 0. It's okay to have and you need charges in net ionic equations, but the charge must be the same on both sides of the equation. So just keep that in mind. Okay, and then the last one that I'm going to do is 2004, letter D, the hydrogen iodide gas is bubbled into a solution of, oh, that was fun, into a solution of lithium carbonate. So I have a gas, so I know the first reactants can be a gas, and the solution of lithium carbonate, that's going to be an aqueous compound. So again, list what your ions are. Hydrogen +1, iodide -1, lithium +1, and then carbonate's going to be +2. So when you go to make your compounds here, your +1, -1 charges will cancel, but you need 2 of these lithium ions to balance out that -2 charge on the carbonate. Okay, and then this is double replacement again, so I'm going to keep the first ion in each compound where it is, and then I'm going to switch the second 2 ions. So now my hydrogen is going to pair up with my carbonate, and my lithium is going to pair up with my iodide ion, like this. Now, this should be a giant red flag in your mind right here when you make carbonic acid. That's going to decompose into water and carbon dioxide gas. So go ahead and make that decomposition happen. Otherwise, you're not going to get the right answer for your complete and net ionic equations. So when I decompose, that's going to be a liquid and a gas. And here, for my lithium iodide, if you look up group 1 metals in the Cash and Gia chart, the GIA, group 1A metals, they're always soluble. And then I have a halogen, and it's also going to be soluble because it's not with silver, mercury, or lead. So either way you slice it, this lithium iodide is soluble. So go ahead and split what can be split. You cannot split the hydrogen iodide gas because it's a gas. Lithium carbonate can be split. It's a solution. Don't split water, don't split CO2, but do split your lithium iodide. Look for your spectators. So the only thing that I have that's the same on both sides is this lithium ion, so it's going to be canceled out. And then I'm left with this in red is my net ionic equation. And again, notice how I'm charged balanced. So over here I have a net charge of a negative 2, and on the right side I also have a net charge of a negative 2. If you're not charge balanced in your net ionic equation, you're going to get dinged for that on the AP exam and on any sort of test for me. So please make sure you charge balance and carry your charges through both your complete and your net ionic equation. So we're going to work some more on this in class. Let me know if you have any questions, and I hope you found this helpful.